Hello and welcome back. In this session, we are going to learn how to rotate a given array. Let's first go through the problem description. Here we have the problem description, uh, and it reads as follows. Rotate a given array to the right by k steps, where k is a non-negative integer. Okay, fairly straightforward. Here is sample input. Let me maximize this. 5, 10, 15, 20, and so on. And then we are asked to rotate this particular array by 4 positions to the right. That means we are not throwing any element out. If you're rotating right, let's say if you're rotating right by one position, k is equal to 1, then this 40 will go all the way, make a circle, and come back uh, in place of 5. And 5 will be shifted by one position to the right. That means 5 will take the position of 10. Okay, and then 35 will take the position of 40. Okay, so it's just rotating it. All right, so if you're rotating by 4 positions, obviously these 4 elements will be kind of going toward the beginning of the array, and first one is the 40 that goes, and then 35, that's how 40 landed here in this particular position, and 35, 30, 25 is the last one. Okay, and then other elements push toward right. Okay, so that's our sample output, and obviously with the given sample input. And the algorithm to do this is something pretty interesting actually. Probably you could just stop the video and then try to come up with an algorithm of your own. Okay, so or you could actually just continue this video and then implement this particular algorithm. How we achieve this is first we reverse entire array, okay, in this case this entire array, and then if we do that, 40 will come here in place of 5, 35 will come in place of 10, right? Everything will be reversed, but that's not exactly what we need, because 40 should go here. This will be in the reverse position. Okay, when you reverse the entire array, it will be 40, 35, 30, and 25, right? We just need to make it just reverse it. Okay, reverse it again. So we reverse the entire array, and then we reverse up to the k position. Okay, and then the other one, that is also reversed. Actually, it will be like 20, 15, 10, 5. But what we need is 5, 10, 15, 20. So that also has to be rotated, right? Rotate entire array, and then rotate for the first k position, and then rotate the length of the array minus k, the remaining elements. Okay, not rotate, sorry, the reverse. Okay, this is reverse, this one also reverse. Okay, after reversing the entire one, that means we are reversing 3 times. Okay, reversing the entire array, reversing k number of elements, and then reversing n minus n, where n being the length of the array, reversing n minus k elements. Okay, so that means our time complexity is going to be if the length of the array is n, and then the number of rotation to be made is k is 4, then our exact time complexity is going to be order of n plus order of k plus order of n minus k. So which is basically the largest one is order of n. So it's order of n. Time complexity is order of n. And the space complexity is we are moving elements, but we are not creating any new space. Okay, we are doing everything in the given space. So it's a constant space. That's why we say order of 1. Okay, all right, so with this we are ready to start programming. Let me just minimize this one. Right, I am going to start my file. First, the Java implementation here in this session. Rotate array.java. Okay, class array. Okay, we start our main method, not def. Public the def is for Python actually. Public static void main string args. Okay, here we will just fill it later. Now first we are going to define the signature for rotate. I'm going to make it private. Static void rotate. So what are we going to rotate? Pass this array and we rotate. That's what we are going to rotate, and then we rotate k number of times. And I don't have that method ready yet, so I'm going to say to do. Okay, I need one more here. That is also private static void. I need to reverse. Okay, since I'm reversing 3 times in my algorithm, that's what we discussed, so I want to make it reusable. And what I'm going to reverse, again I get this is just a name in signature nums int provide start and end. Okay, all right, so basically I'm giving the index, the start index and index. Probably I could say start index and then end index, right? Yes. Or that's start and end is pretty clear actually. All right. Okay, so what are we going to do here? We check one particular condition. Our start should be always less than end, because if that's not true, then we don't have to rotate anything, reverse anything. So here it's just a typical swapping. You store the start element into temporary variable, and then store the element with this start index in the temporary variable, and then from end with the end index you put it in the start index, and then in the end index you put the temp. It's like typical swapping with the help of third variable. It's fairly easy, especially if you have computer science degree. In STEM we must have done this kind of swap many times actually. In temp is equal to nums of start. I need to put in the temporary variable, because next I'm going to set that particular location in array. Start with the n value, I mean nums n number from that position and index, and then and then finally in the nums n I'm going to get the temp. Okay, right, and I need to move my pointer. So it's a kind of pointer actually. I increase the start and then I decrease the n by one position. Okay, so that's how we move, and eventually start less than n becomes false and we come out of the while loop. Yeah, that's it here. Now over here rotate, I'm calling it 3 times, but there is one thing interesting that I need to do. That is, if I give like a rotation, number of rotation, like I have the array of let's say 5 elements and I give the rotation like 10 times. So what's going to be the result here? I mean, even if I rotate 10 times, I'll get all the elements in the same position. For an array containing 5 elements, if I rotate them 10 times, I get the same. If I rotate 20 times, I get the same. If I rotate 15 times, I get the same. So if my rotation element k value is higher than the numbers, I better take the remainder, and then I just rotate those many times. Okay, because for element containing n for an array containing n elements, if I rotate n times or 2n times, or any multiple of n times, is going to be this elements are going to be in the same position, so which is equivalent to not doing anything. So basically you could achieve the result without doing anything. Okay, so this step is going to give a pretty good efficiency actually, in case we have very high number coming compared to the number of elements in the array. Numbers dot length. Okay, it looks simple, but it's going to save a lot of time. And all I'm doing next is reverse, call reverse 3 times. One for my all the elements, nums dot length, all the elements in the array. I'm doing that. I need semicolon in Java. Okay, and then next I need to do for nums 0 to k minus 1. Okay, it starts from 0, so since k is the length, that it will cover all the elements. And finally I do for the remaining elements, which is nums k to nums dot length g minus 1. Okay, so now we define the array. Alright, let's define int array my nums is equal to, okay, where are my elements? My elements are over here, over here. I'm going to minimize this and I'm going to rotate it 4 times. Okay, try it by 4 times. Alright, and next I'm going to just call it, since it's starting method, I can just call it. I don't need to instantiate a class or anything. Remember here I already saw a spelling mistake. Rotate my nums and 4 times. Okay, now it's done. Semicolon. I forget, as I say, that I need it. It's pretty interesting. It's interesting because another language that we're going to use doesn't need a semicolon. Alright, so now that's rotated. We call that rotate. Rotate calls reverse, so it's done. When that is done, I need to print, but in Java I need to do this thing. I is equal to 0, I is less than my nums dot length, I plus plus or plus plus I doesn't really matter here. System out print println. I'm going to say not I, my, because I is the index, so that's how I get my number, and I print comma. Okay, maybe one extra comma at the end, but that's fine, it doesn't bother us. Yeah, it's good to have that comma instead of writing 2 additional lines just to omit that comma, because adding more lines is not difficult, but it will just make program a little bit longer on the part which is not that necessary for us, because we are learning how to implement particular algorithm. So the thing that is most important is these 2 methods here. Okay, other thing is more like we're writing some unit test kind of code. Okay, okay, I need 1 line after that, so that I see my numbers in 1 line and my prompt in next line. Okay, that's why I'm having this line. I think that's good enough. Let's compile and see how many error we get. We'll fix them. Okay, there is 1, reverse I, k minus 1, reverse nums. Okay, cannot find symbol. Line number 14, variable I. All right, okay, line number 14. Let's set our line numbers, and it cannot find symbol here. What is that I, right? So okay, what is that I? Okay, we are first doing the entire array, and then we are doing beginning to, okay, beginning to k minus 1, that means it should be 0, 0 to k minus 1, not I. Okay, and then after that, k to nums length minus 1, that is correct. Okay, Java C, very nice. Java rotate array, that's it, let's see. Okay, we have println there, so that's how you have this 25, 30, 35, 40, 5, 10, 15. Okay, let me do one quick change. Sorry, over here, instead of println, I do just print. I will recompile it and rerun it. Okay, and let's check with our original kind of answer over here. 25, 30, 35, 40, 5, 10, 15, 20. Awesome. Okay, that's exactly what you need. Very easy and interesting problem. Okay, we will implement the same algorithm in Python in the next video.